As we take a look at this next little section of stuff, we're going to see absolute value equations, but what's different now is now we're going to see the expression that is not contained in the absolute value is going to contain at least some variable. And so we want to see how we can go about solving that. So I want to help develop the concept of that before we get into the process of this. So really, it's no different than the equations we were just working with, where we only had where this was just a number instead of having a variable involved. So I'm just going to come up with an example. So how we're going to solve this is going to be just like if you had, let's say, the absolute value of 5x minus 2, and then I'm just going to pick a random number, let's say 16. How about? So if we were to solve this particular problem, we're trying to figure out, okay, if I'm an absolute value stuff, I want it to equal 16, right? So what that tells us is that this right here needs to be worth 16, or it needs to be worth negative 16, right? So then we would say, okay, so I need 5x minus 2 equals 16, then we can solve to figure out what x would make that work, right? Or we need the 5x minus 2 to be worth negative 16, and then we can solve both those equations from there and come up with solutions, right? So it's absolutely no different with what we have going on right here, even when this stuff right here that's not contained in the absolute value, when that stuff right there is algebraic, it's no different, okay? So what we really need to have happen is we need that whatever the 5x minus 2 is going to be worth, we need it to be worth 7x plus 14, or it's negative. And when I say it's negative, I need to put parentheses, or the negative of 7x plus 14, which really is the same thing as negative 7x minus 14, right? So what we're going to do here to solve this is really just say, okay, hey, I need 5x minus 2, the quantity that's in that absolute value, to equal the same expression, 7x plus 14, or I need the 5x minus 2, which is inside the absolute value, to equal the opposite of that, which is negative 7x minus 14. So we get our two separate equations, same sort of stuff we were seeing just earlier. Now you can just solve both of these equations. So I'll go to the first one. I'm going to go ahead and subtract 5x from both sides. That's going to yield us negative 2 equals 2x plus 14. And then from that one, I'm going to go ahead and subtract the 14. That's going to give us negative 16 equals 2x. And then finally from there, I'm going to divide by 2. And that's going to give us our final answer of negative 8 equals x there. And then we'll go to the other equation. So in the other one, we're going to go ahead, how about if we add 7x? And then that gets us 12x minus 2 equals negative 14 then. And then from there, let's go ahead and add the 2, so we get the x term alone. It's going to get us 12x equals negative 12, and then finally we can divide by 12, and that's going to give you an answer there of negative 1 for x. Okay, so we came up with answers, right? So let's go ahead and just check our work and see that what we've done is valid, so just check. So let's go ahead and check negative 8. So in the original equation, we had 5 times x minus 2 in absolute value. That's supposed to equal 7x plus 14. And we're going to check this negative 8 value. So if I plug in negative 8, so right here I've got 5 times negative 8 is negative 40, and negative 40 minus 2 is negative 42. So that's an absolute value. And then I've got 7 times negative 8 is negative 56 plus 14. So if I do that, it's going to be negative 42 when I add them. And then the absolute value of negative 42 is 42. So when you take a look at this statement right here, that's not a true statement. 42 does not equal negative 42, right? That's a false number statement. So what that means is negative 8 is not a solution to the equation, because when we just plugged it in, it didn't give us a true number statement, right? So it seems confusing because, like, oh, we just did all this work and we came up with the answer, right? So what we need to understand as we get into this realm here is that just because we go through steps and we go through a process to come up with what we think is an answer, it's really not an answer unless we can actually prove that it works in the original equation. So what we're encountering now is that sometimes with these absolute value equations, we can go through the steps that we go through to try to come up with an answer, but we really won't know it's an answer until we plug it back in. It's something that we probably just didn't do a lot when you learned how to solve equations, but it's something that's really relevant with absolute value equations. So it turns out that this right here is actually not an answer, and we give it a fancy name that when we plug it in, it doesn't work. It's an extraneous solution. So what an extraneous solution is, it's I'll put in quotations right here, it's a solution that you get as a part of the solving process. So you go through the normal steps that you would to solve an equation, but it does not actually satisfy the original equation or the original problem that was posed, right? Just abbreviate equation. Yeah, so it's kind of a bad name to call it an extraneous solution because it has the word solution, and solution makes you think it's an answer, but it's really not. So if something's extraneous, you go through the steps and you come up with it as an answer, but it's not actually an answer because when you plug it in, it doesn't actually work. Now, what we didn't do is we didn't plug in -1 to see if that's going to work. So let's go ahead and check to see if -1 is going to work. So if we did the absolute value of 5 times x minus 2 again, and then 7 times x plus 14, this time if we plug in the -1, so we're going to get -5 minus 2 is -7 in the absolute value, and then this is going to be -7 plus 14. Okay, absolute value of -7 is 7, and then -7 plus 14 is 7. Okay, so that right there, that's a true number statement. So we know that by plugging in -1, it makes it work. So it turns out that this equation does have an answer of -1, and that's the only answer. We can't acknowledge -8 as being an answer. So just now, right, we're just kind of getting to this territory where there's extraneous solutions. So I do want to help you understand that if right here, if this was only just a number, so if it was like just 4, not with the x, then we don't have to worry about extraneous solutions in those sorts of problems. That's why it was never brought up with the earlier examples. But now, if when you have an absolute value equation, you've got a variable inside the absolute value, and then outside of the absolute value on the other side of the equation, if there's a variable there, you have to check your solutions once you come up with them because they might be extraneous. So with this particular equation, note that the absolute value quantity is isolated, right? This is the only thing we have on that side of the equation. It's equal to 4x. So what that means is that this 2x plus 12, it needs to be worth 4x or the opposite of 4x, and the opposite of 4x is -4x. So we're going to set up two different equations here, one of which is going to say that 2x plus 12 needs to be worth the 4x, or the 2x plus 12 is going to be worth the opposite, which is -4x. And then we'll go through the steps to solve both of these equations, but then we're going to have to check our answers to see if there's any extraneous solutions. So with the first one, how about subtract 2x? That means that 12 is equal to 2x, and then we can divide by 2, and then that's going to give us 6 equals x. So that's a candidate, I'll call it, right? Not necessarily an actual solution until we check it. And then we'll go to the second equation we set up there. Let's go ahead and, how about add 4x to both sides. That's going to get you 6x plus 12 equals 0. And then I guess we can subtract the 12. So that's going to get you 6x equals -12. And then finally we can divide by the 6. So it's going to give you a candidate answer of -2 there. So you really do need to check both of your answers to make sure that they work in the original equation. So let's do that. So let's check 6 first. So absolute value of 2 times 6 plus 12 is supposed to equal 4 times the 6. So we're plugging in the 6. 2 times 6 is 12, plus 12 is 24. 4 times 6 is 24. Okay, so that right there, that's a true number statement because the absolute value of 24 is 24. So great, we know 6 is going to be an answer. I'll highlight that in green. And then let's check the other answer of negative 2. So the original equation was absolute value of 2 times, plug in negative 2 plus 12. So it's equal 4 times negative 2. Great. Okay, so that's negative 4 plus 12 is positive 8. 4 times negative 2 is negative 8. Okay, you can see that that's not going to work because the absolute value of 8 is 8, and that can't equal negative 8. So therefore, we'll just acknowledge that this guy right here, this is an extraneous solution, so it's not an answer to the equation. So the only answer to the problem there is just x equals 6. So I'll just leave what I have highlighted in green there as the answer. Okay, one last one that's similar in nature. So just like with the problems before, if we're solving an absolute value equation and you've got an absolute value quantity and there's a variable inside of it, you need to isolate that before we do anything else. So you can see there's this multiplication by 2 and subtraction of 20 that we need to undo. So I guess the first thing we'll probably want to do is undo the subtraction. So we're going to add 20 to both sides. That means we're going to get then 2 times the absolute value of 4 minus 3m on the right-hand side. And then 2m and 20 are not like terms, so we'll get the expression 2m plus 20 on that side. And then we'll want to undo the multiplying by 2. So we can divide by 2 and then divide by 2. So that means we're going to get the absolute value of 4 minus 3m alone, now on that right-hand side. And then on the other side, both of those terms can get divided by 2. So we get 1m plus 10 then. All right, great. So at this point then, now we know that whatever's inside the absolute value right there either needs to be the positive of m plus 10 or the negative of m plus 10. So I can set up two different equations right here. One where 4 minus 3m is going to be equal to m plus 10, or where the 4 minus 3m expression that's inside the absolute value is going to equal the opposite of m plus 10, and the opposite of m plus 10 would be negative m minus 10. And then we can go ahead and solve both of those equations. So with this one, how about if we add, not 4m, add 3m, and then we're going to get 4m on the right-hand side. Okay, and then we can subtract the 10. That's going to get us 4m equals negative 6. And then we can divide by 4, and you reduce that fraction, gives you an answer of negative 3/2 equals m. Okay, we're going to have to check that, though, because we might get extraneous solutions because we had this variable on the other side of the absolute value. Okay, so the other equation we set up over here, how about add 3m? And then that will give us 4 equals 2m minus 10. And then we can add the 10. It's going to get you 14 equals 2m. And then finally divide by 2. So that means that m will equal 7. Okay, so that gives you your candidate answers, and then you're going to have to go ahead and plug both of those numbers back into the original equation. I'm not going to do so in this video, but it does turn out that when you plug in negative 3/2 in for m there, and then you plug in 7 for m, it's actually going to make the equation work for both of the numbers, so we don't end up with anything extraneous at all in this. So we do get two answers in this particular problem. There are some problems where maybe both answers actually might be extraneous. Sometimes you'll get that to be the case. So you just kind of have to make sure you always check your answers when you've got the variables that aren't in the absolute value when you're solving these sorts of equations, because they might be extraneous.